Components of a microprocessor. Program counter. It is a memory pointer. It is used to sequence the execution of instructions. Program counter always holds the address of the instruction to be executed next. After fetching one instruction, automatically the content of the program counter will be incremented by 1. Memory address register. It is a register that holds the address of the memory location being accessed. So it will act as a buffer in between CPU and memory as well as peripherals. Instruction register. IR holds the instruction until it can be decoded. Some microprocessors may have 2 instruction registers. So one can fetch and save one instruction while executing the previous one. This is what they define as pipelining, which is used to processing the instruction parallelly. Accumulator. The accumulator is a register that is part of the arithmetic logic unit. In all arithmetical and logical operations, one of the operand must be in the accumulator. And the result is always stored in the accumulator. It is implied, whenever we do any arithmetical or logical operation, one of the operand must be in the accumulator and always the result goes to the accumulator. It is implied. General purpose register. It serves as temporary storage for data or address. Normally, the size of the register is equal to the word length of a processor. The intermediate results can be stored in the general purpose registers. For storing the intermediate results, the CPU need not refer memory every time. The intermediate results can be manipulated within the CPU, and for storing the final results, the CPU can refer the memory. If we take 8085, there are 6 general purpose registers, namely B, C, D, E, H and L. These registers are used to store 8-bit data during program execution. We can combine the registers B and C, similarly D and E and H and L. So we can call it as register pairs like BC pair, DE pair and HL pair, which are used to perform some 16-bit operations. For example, the content of HL register pair is used to point the memory. In the case of 8086, there are 4 16-bit general purpose registers, which are AX, BX, CX and DX. This is further subdivided into 2 8-bit registers. H represents higher order registers and L represents the lower order registers, and which can be named as AH, BH, CH and DH, as well as AL, BL, CL and DL. Status register or flag register. A register whose contents reflects the current status of the computer or CPU. It is same as a condition code register. It is a single bit indicators which reflect the result of the operation. In the case of 8085, there are 5 flags, namely sign flag, zero flag, auxiliary carry flag, parity flag and carry flag. Whenever we add 2 numbers, if the MSB becomes 1, it may be treated as a negative number. So the sign flag bit is set into 1. Similarly, if the results become 0, the 0 flag is set into 1, otherwise the 0 flag is set into 0. And when we add 2 numbers, if there is a carry from lower order nibble to higher order nibble, the auxiliary carry flag is set into 1. In the result, if it consists of even number of ones, the parity flag is set into 1. Otherwise, it is set into 0, which is used to verify the bit error during the communication. The last flag is the carry flags. When we add 2 numbers, if there is a carry from the MSB bits, then the carry flag is set into 1. The carry flag is treated as a borrow flag in the case of subtraction. For example, if you add the 2 numbers B9 and DF, take the B9 is 1011, 1001 and DF is 1101, 1111. If you add these 2 numbers, you will get 1 is 0, 0, 0, 1, 1, 0, 0, 1 and carry is 1. So the result is 0198. According to this example, the sign flag is set into 1 because the MSB is 1. The 0 flag is set into 0 because the result is not 0. The auxiliary carry is set into 1 because there is a carry from the lower order nibble to higher order nibble. The parity flag is set into 0 because we have odd number of ones. The carry flag is also set into 1 because there is a carry while adding the two numbers between in the MSB bits. Arithmetic logic unit. It is used to perform the arithmetic operations like addition, subtraction, multiplication, division, increment and decrement, as well as logical operations like AND, OR and exclusive OR. It receives the data from accumulator and registers. According to the result, it set or reset the flags or the condition code registers. The stack pointer. The stack pointer is also a register used as a memory pointer. It points to a memory locations in read bar write memory called the stack. So the stack is a portion of the main memory. We used to refer the stack as LIFO, last in first out memory. The data which is stored during the last machine cycle can be taken out first. So the beginning of the stack is defined by loading the address in the stack pointer. In the case of stack memory, the data are added above and above. Let us discuss about the stack memory little later.